and welcome to this video on even more exponent examples. Previously we've done the exponent laws, a few simpler examples. We then went on to do some more examples and even more examples, and now we're doing, you've guessed it, more examples. Now these ones are different from the previous ones because in the previous ones we've only been dealing with the operations of multiplication and division, and in these ones here we're going to look at how do we deal with those that have subtraction and addition. Okay, so your first step is to break up into prime bases like we always have, but if it is prime bases, then what you have to do is then factorize. So the tool that we're going to use whenever we see addition and subtraction is to factorize. Now this is very important that you don't forget it. So we're looking at the numerator. I'm going to start with a step where I break it down just so that you can see the factorization a bit clearly. So this, I'll write it over here. 5 to the power of x plus 1 is 5 to the power of x times 5 to the power of 1. Since when we multiply, we add. So we're just going to do the reverse of that operation. And then that's minus 5 to the power of x over. And then we're going to do the same thing in the denominator. So that will break up to 5 to the power of x times 5 to the power of minus 1. Now we look at the numerator and we see what is common. So here we have a 5x in this term, and here we have a 5 to the power of x in this term. So that is common and we're going to take it out. What is remaining? Well, here is 5 to the power of 1, which is just 5. And here, when we divide, that's what we're doing when we're taking out a common factor. We don't get nothing, as some of you might write. It is 1. So remember, if you're dividing by the same thing, you're getting 1. Doing the same thing in the denominator, 5 to the power of x is common again. We take it out. What we're left with is 1 plus 5 to the power of minus 1. Okay. Then what we have is multiplication now is the operation over here. So the 5x's cancel. 5 minus 1 is 4. And 5, this is 1 plus 1 over 5. So this here is 4 over, making this as mixed number, it's 6 over 5. And that is 4 divided by 6 over 5, which is 4 times 6 over 5, which is 24 over 5. Okay, so that wasn't too bad. Let us look at another example. So again, we have subtraction in the denominator. So the trick to dealing with that is factorizing. Remember, you can never, ever, 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 ever cancel over addition and subtraction. So we always have to factorize. So I'm going to start with the same step by breaking it up. So that's 7 times 3 to the power of n times 3 squared over, and I'm going to break up the denominator. That's 3 to the power of n times 3 to the power of 3 minus 6 times 3 to the power of n times 3 to the power of 1. Now, in the numerator, we don't have a common factor because there's only a multiplication over there, but so we write the numerator as is. And in the denominator, we're going to take out the common factor. Now, what we have is 3 to the power of n times, okay, so I'm just taking out the one with the variable, so the rest I didn't really simplify it as simple as it could be, but you could take out a higher factor if you wanted to. There's no problem with that. So once again, this is multiplication now, so that cancels with that, and we have 7 times 9 all over, and this here is 27 minus 6 times 3, which is 18. And then we just simplify that to get our final answer. So this here is 7 times 9. 27 minus 18 is 9. The 9's cancel out, and what we're left with is just 7. Okay. Once again, you could have taken out a higher common factor here. You could have broken up that 6 and write it as 2 times 3. And then here you could have taken out 3n plus 2. Okay, so you'd take out another 2 3's. Okay, but anyway, that is the one that we've done. Next one. So here we have our question again. First step is the same. We break up. 2 to the power of 3 minus 3, 2 to the power of n times 2 to the power of 2 over 2 to the power of n times 2 to the power of 1. So we've broken it up. Now we're going to look for the common factor. So what's common is 2n, 2 to the power of n. So we're going to take that out as a common factor, and what we're left with. Oh, and so in this case, I'm going to take the absolute highest factor. So again, this one has 3 2's and this one has 2 2's. So I'm going to take out 1 2, and you'll see why in a second. So if I take out the 2 to the power of n, I'm going to have 5 times and then 1 2. So there are 2 left, minus 3 times 2 all over 2 to the power of n times 2 to the power of 1. Okay, so that cancels out with that cancels out with that, and all we left with that, which is 5 times 4 minus 3 times 2, which is 20, minus 6, which is 14. Okay, that one was also very nice. Another question, again, we've got the subtraction over there. So again, our trick is to factorize. I'm first going to break it up. You don't have to break it up if you don't want to. I just break it up so that you can see how I'm taking out the common factor. If you don't want to, you don't have to. Okay, so I've broken it up. Now look in the numerator, there are 3 terms. Terms are separated by subtraction and addition. So there's 1, 2, 3. So what's common between these 3 terms? Well, it's the 2 to the power of x. And what's left is 3 times 2 minus 2 to the power of minus 2 plus 1. When we divide by the same thing, all over 4 times 2 to the power of x times 2 to the power of minus 3. Once again, that will cancel now that we have multiplication, and then we simplify. This is 6 minus a quarter plus 1 all over 4 times an eighth. So I'm just simplifying. So this here is 6 3/4, which is 25 over 4. Is it? 24? No, it's not. So that's 24 over 4 minus 1 over 4. 23 over 4 plus 4 over 4 is 27 over 4. And I'm just going to write this denominator as divided. It's 4 over 8, which is a half. So it's 27 over 4 times 2 over 1, which is 27 over 2. Okay, next one. Okay, same steps. First, we're going to factorize. Okay, now this one is a bit different. We're first going to break that into prime factors. So that's 3 squared to the power of x minus 3 to the power of 2x times 3 to the power of minus 1. I've broken it up over there. And then I'm going to distribute that. So it's 3 to the power of 2x plus 2. So this is 3 to the power of 2x. So I've just multiplied that. Minus 3 to the power of 2x times 3 to the power of minus 1. Or over 3 to the power of 2x plus 2. I'm going to break actually the bottom one up. So I'm going to write it times 3 to the power of 2. Then once again, look for a common factor in the numerator. So it's 3 to the power of 2x. And what we left with is 1 minus 3 to the power of minus 1 over 3 to the power of 2x times 3 squared. That cancels. This is 1 minus a third over 1/9. So 1 minus a third is 2/3 divided by 1 over 9. So that's 2/3 times 9 over 1. So 3 goes once there, and 3 times there. So your answer should be 6. Okay, so these were very important questions. They were the ones where we had addition and subtraction. So when you see addition and subtraction in your exponent sums, what is the trick? I hope you learned it is to subtraction. Sorry. So the trick is to factorize. Okay, and remember that trick. It's going to save you a lot of time and earn you a lot of marks. Please show these videos to your other friends. Comment, like, subscribe, and thank you for watching.